Let's begin. Today's June 30th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards and its 6 verification cards. Let's go to turingmachine.info for the details. So today's puzzle uses the following 6 criteria cards. Criteria card 5, 9, 12, 19, 20, and 22. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A looks at the first digit, the triangle digit, and the Turing machine will let us know whether its value is an even or an odd. Criteria card B will look at our 3-digit solution and will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2 are 3? Or maybe even all 3 are 3. Criteria card C will compare the first and last digit, the triangle and circle, and comparing them, the Turing machine will let us know whether the triangle value should be less than circle, should it be equal to circle, or should triangle be greater than circle. Criteria card D will look at the first 2 digits, the triangle and square, take their sum, and compare that to the number 6. So should the sum be less than 6? Should the sum be equal to 6? Or should the sum be greater than 6? Criteria card E will look at our 3-digit solution and will let us know a little bit about how it's structured. Specifically, it will let us know whether there are no repetition among the 3 digits, basically stating that they are all unique, like in the example 125. Or potentially it could have a double number, a repeating digit, as in the example 112, or possibly it may even be a triple number, a single digit repeated 3 times, as in the example 222. And finally, criteria card F again will look at the 3-digit solution and will let us know something about how the digits are ordered from triangle, square to circle. In that order, potentially they could be ascending, meaning that they are increasing, so as in the example 135, or they could be descending or getting smaller, as in the example 421, or potentially even they may have no order, as in the example 231. So if you look at the example 231, it's no order because if you notice, it goes up from 2 to 3, so it increases, but then notice that it goes down to 1, so it decreases. So that shift from increasing to decreasing, or potentially decreasing to increasing, is one way to define that the 3 digits have no order. Remember, the objective of the puzzle is to find this one unique 3-digit solution that abides by all of the 6 criteria cards we just described. So let's begin with a proposal of 314, and the first thing I want to test is whether that first digit is an even or an odd. So I'm going to test criteria card A. Okay, so the Turing machine does not approve of my digit value for triangle. Notice that I do have an odd 3. So basically it's telling me no, odd is not correct. So therefore it must be true that triangle is an even digit. So that's what I'm going to type in section A, that triangle is an even digit. And since it is an even digit, let me go ahead and cross out all the odd values for triangle. So it can't be 1, it can't be 3, and it can't be 5. Okay, so what else do we have? Let's go ahead and see what we can find out about the whole 3-digit solution. So let me go ahead and test criteria card E. Okay, so it does approve of my proposal of 314. Notice that my example or my proposal, I don't have any repetitions. So just like the example of 125, all of my digits are unique. So that's what it's basically telling me, is that the solution has no repetitions. So I'll just type that up in section E. So no repetition. So basically they are all unique. So that means that if I have a 2, no other digit can be a 2, and if I have a 4, no other digit can be a 4. And let's see, what else? So the only thing we know so far is that triangle is even. We really don't know about square and circle. So at this point, if there is an odd, well, if there is an odd, actually, there you go. If there is an odd, that means either the 3 is there or it's not. Because again, no repetitions. So there can't be 3 3s or can't even be 2 3s. So it's either there or not. So that is a 50-50. I think I would rather test. I'm trying to think of if I should test either C or D. And I'm trying to think of, since we don't know what square and circle are, somehow we'll end up with that. So square and circle. This is interesting. This is an even, and it's going to be comparing it with circle. I wonder if somehow circle might end up being even, and it'll be a way to sort of order the evens for triangle and circle. And then perhaps maybe square is a 3, potentially. But if that's the case, maybe not. I'm not sure. So let me go ahead and I'm going to test criteria card C. Okay, so the Turing Machine does not approve of the way I sorted or ordered my triangle and circle. So notice that my triangle value is 3 and my circle value is 4. So it's not true that triangle should be less than 4. And also remember, since there are no repetitions, it can't be equal. So that means that in fact, triangle should be greater than circle. So let me go ahead and type that up in section C, that triangle should be greater than circle. And since triangle should be greater than circle, what can I do? Well, it can be true that circle is 5, because if circle's to be the smaller of the two and it's 5, that you couldn't have anything for triangle. And let's see, and I think that's it. You can't cross out the 2 because it makes sense, 2 is bigger than 1. Now, because I also have at most a 4, that means I can actually even cross out the circle 4 for circle, because again, triangle's has got to be bigger. So that means I can actually cross out 4. Okay, so that's very cool. Okay, well, I think that does it for this round, I've already done my 3 Turing tests. So we're going to go into the phase where we're going to be discussing and talking about how to construct a good second round proposal. Okay, so I did not test 3. And again, we know that it should be a 50-50. It's either there or not. And then we also have criteria card D that takes the sum of the first 2 digits and compares it to 6. And we already know that there's no repetition. So, and finally, there's the question of how the digits are ordered. So let's see. So I think we could eliminate, this is interesting, ascending order, because if triangle were 4, then square would have to be 5, but then there's nothing left for circle. And even with triangle is 2, if it's ascending, it would have to be 3 and then nothing else. So it's either descending or no order. So at least, okay, so that's interesting. Because it cannot be ascending. Oh, this is very interesting. Can we eliminate the 4? No, of course not. Because again, it can be descending or no order. Never mind, not sure what I was thinking. So no, we can't eliminate 4 because of course we can still have a no order. Okay, so again, B, if there is a 3, it's either going to be in square or circle. We have this sum of the first 2 digits, and then there's the no order. So again, so we could have, let's see, if it's descending, it couldn't start with a 2 because then you'd run out of digits. What about 4? Yeah, there are a couple of possibilities with 4. So it could be 4, 3, and then 1 or 2, or 4, 2, 1. So that would be interesting. And there are, I guess, a couple of possibilities. Oh, that's also interesting. We also know that triangle has to be greater. Oh, this is interesting. Triangle has to be greater than circle. So if triangle is supposed to be greater and triangle starts off with 2, of course it wouldn't be descending. So it would be something like maybe 2, 3, 1. So it would have to be triangle 2, circle 1, and then it could be a 3 or 4 or 5, and then a 1. So there would be, well actually, yeah, well it couldn't be 2, 1 because there's no repetition. Yeah, it would have to be 2, 3, 4, 5, and then the 1. That's interesting. Okay. And in all those cases, they would all be no order because they would go up and then down. That's interesting. Could we eliminate? That is interesting. Yeah, they all. So what would distinguish them? Well, 2 of the cases, I guess, would be distinguished by criteria card B that there's a 3 or not. So it would be 2, 3, 1. That's how you would distinguish between 2, 3, 1 and 2, 4, 1 and 2, 5, 1. So I think 2, 4, 1 and 2, 5, 1 are ambiguous. Although, I guess criteria card D could also distinguish actually all of them, because 2, 3 is less than 6, 2, 4 is equal to 6, and 2, 5. And 2, 5 is greater than 6. Very interesting. And then if triangle were 4, I think there are just way too many possibilities. But we've got to narrow it down. So there is no 3. If there are no 3s, and we block all of that, I'm not sure. And 4, 4, 5. Yeah, it looks like if triangle were 4, there just seems to be too many possibilities. If it's 4, 5, then it would definitely be no order. But if it's 4, 3, then it would be descending. Okay, well, and what about that sum? Could it be 6, 2, 4, 3, 4, 2, 3? Yeah, it could be 4, 2, 3, maybe even 4, 2, 4, 2, 1, where there is no 3. It would force circle to be 1. Let me go ahead and try that out. 4, 2, 1. I'm thinking maybe it's descending. Let's see. Okay, yeah, let's go for it. Okay, so let's go ahead and test this criteria card D, the sum. Okay, so it is not 6, which would mean that it could not be an even for square, because if I do, well, no, I take that back. Yeah, actually, we know we can't have duplicates, so if it were a 2, it won't be a 4. I mean, obviously, if it's a 2, it can't be a 2 for square. And if it's going to have another even, that would be 6, and same thing. So yeah, I feel confident that, yeah, we can cross out the remaining evens for square. That's the only way we could get a 6. Yeah. Okay, that's interesting. So let me go ahead and also type in that triangle and plus square must be either less than 6 or greater than 6. Less than 6 or greater than 6. So let's see. So if it's a 2, well, yeah, I think, yeah, it's still wide open. There's nothing really to tell us anything about that. Interesting. So if we do have an odd for square, is there anything we can deduce about circle? Okay. So we haven't tested if there's a 3. So I didn't pick a 3, but again, it's a 50-50. So let's go ahead and test criteria card B. Okay, so I was wrong. The Turing machine does not approve that there isn't a 3. So that means that there is a 3. There is a single 3. So that's B. So there is a single 3-digit in our solution. Okay, so very interesting. So what if I chose 3 for square? Well, we would have less than 5 or greater than 5, or sorry, less than 6 or greater than 6. Very interesting. And then I guess we haven't tested we have not tested criteria card F, talking about the order. Well, I did choose descending, so let's see if that's still correct. Okay, so it's not, so that means it has no order. So no order. Okay, so very interesting. So, yeah. Okay, so wow, going into a third round, now thinking about how to construct our third round proposal. So we do have no order. So yeah, well, let's see. Let's think about if we can start listing out some potential solutions. So if it has no order, it wouldn't be 2, 1, because again, circle must be smaller and have no repetition. So it can't be 2, 1. So it's got to be 2, 3, 1. Or 2, 5, 1. So the 2 for triangle forces circle to be 1. There's no way around that. Okay, and I believe those are the only 2 possibilities with triangle as 2. Oh, and it can't be 2, 5, 1 because there's no 3. Okay, so we can actually cross it out. So the only possible solution that starts with a 2 must be 2, 3, 1. Okay, well, what about 4? So it could be 4, 1, 3. That's possible. 4, and it could be 4, 1, 2 because there's no 3. And I believe that's it for 4, 1. 4, 1, 3. And it can't be 4, 3 because that would all be descending. And then it could be 4, 5, 3. Okay. And I think perhaps, if I'm not mistaken, I think 2, 3, 1 and 4, 1, 3 are ambiguous because they both have a sum of the first 2 digits that are less than 6. This is the only one that's greater than 6. So yeah, I think we narrowed it down to 4, 5, 3. And I'm hoping that I didn't miss anything. Yeah, it can't be 253. 251, 2. Yeah, it can't be 253 because it has to be less than 413. Yep. 412, no, because there is no 3. And it can't be 43 because that's all descending. And then 453 because you need 3. Yeah, so it looks like 231 and 413 are ambiguous because they both have a sum that's less than 6. So I'm going to cross these out. And we're basically deducing that the sum has to be greater than 6. So let's go ahead and type up our solution of 453. So luckily we didn't have to do a third round. And just really quick, the first digit is even. Yes. There's a single 3. There is. Our first is greater than our last. Yes. Again, we're deducing that it's greater than 6. There are no repetitions and there's no order. It goes up and then it comes down. Okay, looks like a winner. Let's go verify. 453. 453. Excellent. But of course, we've got to do our comparison to the Turing machine. Now, luckily, we did do each one once, so that's always a good indication. And the only valid one that we had was E. So we did ACE with E being the only correct one. So ACE. And then in the second round, everything was incorrect. So it's amazing how we get all these X's, yet we still can come up with a correct solution. Okay, so we tied it. I was anticipating that, whenever you get an equal number of Turing tests versus the number of criteria cards, at a minimum, if you achieve that, it's very likely you'll tie, but maybe even sometimes you may even beat the Turing machine. So like I said, all those X's still were not a deterrent to solving it and getting the correct answer. We're just eliminating possibilities that aren't correct. So we do learn stuff from our mistakes. Well, that's it for today's puzzle. If you found anything interesting that you'd like to add a comment, please do so. I definitely would like to hear your ideas. And if you liked the video, please do give it a thumbs up. And if you don't want to miss out on any future videos, make sure to subscribe to be notified. Well, until next time, have a great one.